Your bank account starts with $100. Each week, $6.50 is added to your account. Create a table and what that would show for the first 6 or 7 weeks. So at 0, we said we have $100. Right? And then we said, well, if I take this $100 and I add $6.50, then that's going to tell me $106.50. And if I add $6.50 to that, well, now I'm at $113. I'm going to add $6.50 to that. I have $119.50. And I'm going to add $6.50. Now we're at $126. I'm going to add $6.50 again. We're at $132.50. And add $6.50 again. And we're at $139. So, how do we do that? Well, every time we went down, we added $6.50 each time. All right, well, what would that be for situation B? Well, let's take a look. Now your bank account starts with $100. So again, we're going to do $100. Okay, and each week the amount of money is multiplied by 1.4. Find out what it's going to be in 7 weeks. Okay, so now what we have is we're going to start with $100. But now I'm going to take that and multiply it by 1.4, it says. And that would be 140. I'm going to take that and multiply it by 1.4. That'll be 196. Take that and multiply it by 1.4. $274.40. I'm going to take that times 1.4. $384.16 times 1.4. $537, and we'll say 82 cents. And times 1.4 one more time, and we have $752.95. And how were we doing that? Well, each time that we were going down, we were multiplying times 1.4. All right, so similarities. Well, we can say that they were both going up and they both start at 100. So both start at $100. And we can also say both are increasing. Okay, what are the differences? Well, for A, we are adding each time. We're going to call that a common difference. It basically just means what is the difference between the numbers? Well, I'm just adding 650 each time. Plus 650, common difference. The difference is 650 between them. For situation B, we're multiplying to get to the next number. So for multiplying, we call that a common multiplier. Common multiplier. Okay, so there's our two different types of things. Situation A, we can say This is a linear function because we're adding each time. And table B is what we call an exponential function because we're multiplying each time. So we have a linear function for table A. Table B is an exponential function. All right, let's take a look at one problem on our example on our notes today. I'm sorry, on our assignment, so that way you can understand a couple other things. So let's look at example 3. And the question is this linear and a common difference, or is this exponential and it has a multiplier? Well, how you determine this is you start from the bottom. So you take this 4.3218, and if it's a common difference, I'm going to subtract the number before it. Okay, and that tells me negative 1.82. Now, I want this to be common, so what I'm going to do is I'm going to take the 6.174 and now subtract the number above it. And it's not the same number. These two are not the same. So what that means is it's probably going to be a common multiplier. So we'll do the same thing. Take 4.3218, but now I'm going to divide it by 6.174. And that tells me 0.7. So my next question is, what if I do it again? Take the 6.174 and divide it by 8.82. Hey, that's 0.7. If I continue this, 8.82 divided by the number above it, 0.7. So as I do this each time, this is multiplying by 0.7.